Off today with just a quick review and reminder of a concept that we have already done for the past month or month and a half, the slope-intercept form. Who can tell me again, what does slope-intercept form look like? What is the equation for slope-intercept form? We'll go with Leona. What is the equation for slope-intercept form? Not the equation for slope, but y equals what? Slope x plus b. And remember, slope is the variable m. So it's like y equals mx. And then it's plus or minus. It could be minus as well if it's a negative. The y-intercept, which was the letter b. So b represented that y-intercept. Okay, so slope-intercept form is written as y equals mx plus b, where m represents the slope and b represents that y-intercept. So when I'm given an equation that's not in slope-intercept form, so this is standard form, right? ax plus by is equal to c. That is standard form. I want to rewrite it into slope-intercept form. Remember, the process of rewriting is just a two-step process. We move the x over to the other side, right? Y is supposed to be on one side, x is supposed to be on the other side. And then we isolate y by dividing by its coefficient. We divide everything, every value, by that coefficient. So in order to move the x, that 8x, over to the other side, we're going to have to do the inverse of 8x. The inverse of 8x is to subtract it. Remember, I don't want to just move the value, the number. I want to move the entire term. To move an entire term means you have to add or subtract. When you want to isolate a variable is when you do multiplication or division. To move an entire term, though, is addition or subtraction. So we're going to subtract 8x from both sides so that we can eventually just cancel it here, and we're left with a positive 4y is now equal to negative 8x plus 40. I like to put the variable first and then the constant second. The reason I can say plus 40 is because of the fact that it is a positive. The last thing, again, that we're supposed to do is to isolate the y using division. So we're not just going to divide the y by 4, and we're not just going to divide the x term by 4. We divide every number that we see by 4. Every number gets divided by 4. So that way the y is isolated. So we then get y is equal to, what is negative 8 divided by 4 as a class? What's negative 8 divided by 4, guys? Negative 2. That's our slope. Negative 2 is the slope value. And then we have a positive 40 divided by 4. What is that going to equal? 10. So we have plus 10. That's going to be our y-intercept. Now to graph it, remember, when we graph it, we first graph what point? Allison, what point do we graph first? The y-intercept. So the first thing that we're going to do is graph the y-intercept. So the y-intercept happens to be located at the point 0, 10. The y-intercept is located at the point 0, 10. So I start at the origin and I go up positive 10. That's my y-intercept. Then I use my slope as a direction, like a GPS. It's telling me which way to turn. So slope is the direction that you're going to be following from that y-intercept. Now there are two directions that you can navigate. We could write the slope as a -2 over a +1, which indicates that we would go down 2 and then to the right 1. So I can start at my y-intercept, go down 2 and to the right 1, down 2 and right 1, and I can keep doing this over and over and over again as often as I would like. Or I could do the reverse. I could put a +2 on top and a -1 on the bottom. They both are the same thing as just -2 as a whole. But a +2 would mean I would go up 2, and then a -1 means I would go left 1. So again, starting at the y-intercept, I could go up 2 and then to the left 1, and I could follow that process as many times as I can. And it forms a wonderfully straight dotted line that we have here. We would then just go ahead and connect those to create our lined equation. Okay, that's just a refresher of what we have already done. You guys took a test on this already. He's on his way. Thank you. Alex, this will be posted on Google Classroom tonight. Okay? Because you're going to need to know it. All right, go ahead and turn the page to the next. So we have focused primarily on graphing lines based off of slope-intercept form. But you don't always have to graph based off of slope-intercept form. In fact, you can graph an equation by graphing just 2 points. And those 2 points can be your intercepts. So you already know how to find the y-intercept. What I'm going to show you today is how to solve for your x-intercept when given an equation. So just like the y-intercept is the point that crosses the y-axis, the x-intercept is the point that crosses the x-axis. And it's the coordinate of your x. It's your x coordinate of the point where the graph crosses the x-axis. So it's also known as where y is equal to 0, and it's written as the point x, 0. So the point where y is equal to 0, and we graph it as a point x, 0. So whatever your x value is, 0, because y will always be 0. And when we're looking at it on a coordinate plane, so if I draw a quick little coordinate plane here, and I draw a line, we already know this point up top to be our y-intercept. And that's when x is equal to 0. This is what we've already known. We've done this before. Now we're introducing this point, the point that's crossing that x-axis. And that is our x-intercept, where y is equal to 0. So just by having those 2 points plotted, you can create, God bless you, you can create your lined equation. Now, sometimes the line that's given to you or the equation that's given to you is in slope-intercept form, and that's perfectly fine. You're able to state what your intercepts are. And in fact, automatically, when it's in slope-intercept form, you don't have to do any kind of manipulation or math to be able to tell one of those coordinates. Remember, if it's in slope-intercept form, which intercept do we already know, Jose? When it's in slope-intercept form, which intercept is already given to us? The y. The y-intercept is already given to us by that plus or minus b. That plus or minus b value is already one of your intercepts. So here, Let's go ahead and write down that we're going to state the intercepts. So when we're given the equation y is equal to 2/3 x minus 2, we already know that that minus 2 happens to be our y-intercept. And it's located at the point 0, -2. So I can right now, I can just go ahead and graph that point. I can graph 0, -2. I would start at the origin and just go down 2 spots. And that's where 0, -2 is going to be located. To be able to perform the x-intercept or define the x-intercept, that's where I have to do a little bit of work, okay? For your x-intercept, which is what we're learning about now, you would need to plug in y equaling 0 because your x-intercept is at the point where y is equal to 0. We just stated that up here in the definition. Y is going to be equal to 0. That's our x-intercept. So all we're going to do is with this equation, we're going to replace the y value with a 0. So if we have y is equal to 2/3 x minus 2, we're going to replace the y with a 0. So we now have 0 is equal to 2/3 x minus 2. This is just a two-step equation. A two-step equation. And if you look at the backboard where it says solving equations, step 4 and step 5 is where we start off those two-step equations. When we get to step 4 and step 5 on that board, that's where I'm showing you examples of two-step equations. The first thing that you would have to do is get rid of the constant. You get rid of the constant by adding or subtracting. The last thing that you would have to do is get rid of the coefficient by either multiplying or dividing. Okay, so looking up here, let's get rid of the constant first. Are we going to add or subtract? Add. We're going to add, and in fact, we're going to add 2 because the 2, that minus 2 is our constant. So we're going to add 2 to both sides. When we add 2 with the 0, that's just going to give us a positive 2. On the right side, we're left with 2/3 x because the minus 2 and the plus 2 have canceled each other out. Right? They're 0 pairs. So we're left with 2/3 x on the right side. Now to finish solving, we're just going to go ahead and divide both sides by the coefficient. We're going to divide both sides by 2/3. But this is something you should know. When we divide by a fraction, what operation are we really doing? Multiplication. Good. And we are really multiplying by the reciprocal of the fraction. So we're not going to divide by 2/3. We're really going to multiply by 3/2. Remember, there's no such thing as division of fractions. It's all just converted into multiplication, but you multiply by the inverse or the reciprocal of that fraction. Okay, so I'm going to put in parentheses. What we're really doing is we're going to do 2 times 3/2. That's what we're really doing. We're just doing 2 times 3/2. And these go ahead and get simplified out. So 2 times 3/2 is going to give us 3. So we end up with x equaling 3. So the coordinate, this is supposed to be a point, is going to be at 3, 0. Remember, the y-intercept was 0, y. Your x-intercept is your x, 0. So we're going to graph the point 3, 0, which means we start at the origin and we're going to go right 3 spots. And then at the end, all we have to do is connect them to create that straight line. And then we're done. I want you guys to try example number 2 on your own, please. All right, let's go ahead and continue on. For example number 2, we've got y is equal to negative 1/2 x plus 5. Elisa, what is the y-intercept going to equal? 5. Correct. So remember, our y-intercept is already easily noted by whatever you are adding or subtracting as your constant in your equation when it's written in slope-intercept form. So we can go ahead and graph that at a positive 5 on the y-axis. Okay, for our x-intercept, to be able to identify the x-intercept, we're going to have to go ahead and solve. What are we going to replace the y with again, Matthew? 0. We're going to plug 0 in for our y value when we're trying to solve for our x-intercept. So we're going to have 0 is equal to negative 1/2 x plus 5. Aiden, what is the first thing we're going to do? Minus 5. Very good. We're going to subtract 5 from both sides. Remember, the positive 5 and the negative 5 or minus 5 will cancel each other out. 0 minus 5 is going to give us a negative 5 equals a negative 1/2 x. Philip, what's the next step? Okay, good. And we're going to divide it by negative 1/2. But again, what is division for fractions? Multiplication. So really, in parentheses, I'm going to write down that we're really doing negative 5 times a negative 2 over 1, or just a negative 2. We're really doing negative 5 times negative 2 over 1. What's a negative times a negative again? Positive. So this is going to come out to a positive 10. So everyone should have gotten that x is equal to a positive 10. And as the point, that would be written as 10, 0. 10, 0. So that means we're starting at the origin, and we're going to go 10 spots to the right and graph that line. What kind of slope is it? Is it positive, negative, 0, or undefined? Omar? Negative. It is a negative slope. We don't even have to know that we don't even have to look at this. We can just look at the picture, and that's graphed as a negative slope. Okay? All right, now down here at the very bottom, I wrote down standard form, just as reminders of what standard form looks like. It's in the format of a times x plus b times y, and that's equal to c. ax plus by is equal to c. That is standard form. And so not every single one of your problems is going to be written in that slope-intercept form. They might be written in standard form, but you don't have to rewrite. You can leave it in standard form, and it's just as easy to be able to solve for both of your intercepts when it's written in standard form. In fact, some people tend to like it in standard form better. They think it's easier to solve for your x and y intercepts when it's in standard form versus being in slope-intercept form. Let me show you why. Let's go to the next page. So for example number 3, we've got it in standard form. 4x minus 3y is equal to 24. What I'm going to go ahead and do is I'm going to split this little space up into 2 sections. I'm going to label one of them as my x-intercept section, and the right side I'm going to label it as my y-intercept section. Now remember, for x-intercept, when we're solving for the x-intercept, that's the point at which y would be equal to 0. And when we're solving for the y-intercept, that's the point at which x is equal to 0. So if I have the equation 4x minus 3y is equal to 24, and I'm saying that y is equal to 0, and I plug 0 in, what's going to happen to that negative 3y? If I replace that y with a 0, what does this become? 0, right? -3 times 0 is 0. 87 times 0 is 0. Anything times 0 is 0. So it's almost as if I can put a box around it and make it disappear, because that's what a 0 does. It eliminates it. When you're multiplying by a 0, it's as if it never existed. So when we're trying to solve for our X-intercept and it's in standard form, you can just cover up that Y and you've got a one-step equation that you're solving. It's that easy. So we really have 4x is equal to 24. How do I solve that? Mylin? Divide it by 4. 24 divided by 4 is what, Brian? 6. So we're going to get x is going to be equal to 6. That's going to be at the point 60. I'm going to plot that by moving 6 spots to the right on my x-axis. And the same thing is going to happen for my y-intercept. I have that equation 4x minus 3y is equal to 24, but now I'm replacing my x with a 0. So it's as if that 4x never even existed, and I'm left with the equation negative 3y is equal to 24. So I will divide both sides by the negative 3. Matthew B., what do we get? Negative 8. Y is going to be equal to negative 8. So now I'm at the point 0, negative 8. So I start at 0 and I go down to negative 8. And then I graph it and connect. What kind of slope is it going to have, guys? Positive. And I didn't even have it in slope-intercept form. It's not even in slope-intercept form, but I can tell automatically that it's a positive slope just from graphing it. It's pretty simple. So once again, when it's in standard form, if you're solving for your x, just ignore the y. If you're solving for the y, just ignore the x and pretend like they don't exist. But don't forget that your operation in between will indicate whether it's a y or an x that you're working with. Okay? I want you guys to try example 4 on your own. Only do example 4. I want to see where you are from there. Okay, Trey, what did you get for your x-intercept? Negative 2 is correct. Remember, we're going to go ahead and make the y disappear. So all we are left with is negative 5x is equal to 10. We would then go ahead and divide both sides by negative 5, and that would give us x equaling negative 2. So when we plot it, we're going to plot it at the point negative 2, 0. For the y-intercept, let's go with Idrissa. Idrissa, what did you get for your y-intercept? Negative 5. Good. So again, our x value is then going to go ahead and disappear, but we have to maintain that that minus 2y becomes a negative 2y. So we have negative 2y is equal to 10. We'll then go ahead and divide both sides by negative 2 and get y is equal to negative 5. When we plot it, we're going to plot it at the point 0, negative 5. What kind of slope is this line going to have, guys? Negative. Okay, so we'll graph it together and create that straight line. Any questions? All right, do the next 2 examples on your own. And when you finish those 2 examples, feel free to grab your computer and begin your quizzes assignment. Okay, real quickly, for example number 5, Abby, what did you get for your x-intercept? That's the wrong one. Example 5. 2, positive 2. So remember, y is going to be equal to 0. We're going to go ahead and get rid of the y, and we're left with 4x is equal to 8. We would then just divide both sides by 4 and get x is equal to 2. We would plot it at the point 2, 0. For the y-intercept is going to be equal to what, Malia? For example number 5. 4. Okay, we're going to go ahead and pretend like the x doesn't exist, so it leaves us with a positive 2y is equal to 8. We would divide both sides by 2 and get y is equal to 4 and plot it at the point 0, 4. Again, that's going to have what kind of slope? Negative. A negative slope would be located here. Okay, let's take a look at the next example, problem 6. Ashley, what did you get for your x-intercept for problem number 6? Negative 6. Okay, so we're going to make the y disappear. That leaves us with 6x is equal to negative 36. We would then just divide both sides by 6 and get x is equal to negative 6. That gets plotted at the point 0, negative 6. Oops, wrong spot. 0, negative 6. And then what about for our y-intercept? Samantha, what did you get for the y-intercept for problem number 6?
6.
For the y-intercept. Here, walk me through it. What's going to disappear?
6x.
The 6x. So the 6x is going to disappear, and what are we left with?
We're left with negative y and negative 36.
Okay, and then what do we do?
Divide by negative 4.
Okay, and what's negative 36 divided by negative 4? 9. Very good. So we're going to have the point at, that should be 0, 9. The first one should say negative 6, 0. My bad. Whew, no wonder I plotted it wrong. Negative 6, 0 would be our x-intercept. Okay, so we have 0, positive 9 located here. And then when we graph it, what kind of slope is it? Positive. All right, you should be working on your quizzes assignment. It is due before the end of, before the start of class tomorrow.